This calculation comes from a previous examination paper, and it is two conductors connected in parallel. It reads as follows. A copper conductor that is 1000 meters long is connected in parallel to an aluminium conductor of the same length. When a current of 90 amps is passed through the combination, the current through the copper conductor is 55 amps. The diameter of the aluminium conductor is 4 millimeters, and we need to calculate the following. So as you can see by the diagram we've drawn, we have a total current of 90 amps, 55 amps is passing through the copper conductor, and 35 amps is passing through the aluminium conductor. It's important to note that voltage stays the same in parallel. The length of each conductor is 1000 meters. The resistivity for copper is 0.018 micrometers, and the resistivity for aluminium is 0.028 micrometers, and the diameter for aluminium is 4 millimeters. So to calculate the resistance for the aluminium conductor, it is the resistivity times the length all over area. Okay, so before we can substitute those values, we must first calculate area. So the area is equal to pi d square over 4. So look at this, pi, the diameter is 4. To convert millimeters to meters, divide by 1000 square over 4, and that will give us our area for the aluminium conductor. And the area we get there is 1,257 times 10 to the minus 5 meters square. Okay, so if we substitute, the resistivity for aluminium is 0.028. Now to convert micrometers into ohmmeters, we multiply by 10 to the power of minus 6, and the length for both conductors is 1000 meters. So we substitute the area here. The area is 1,257 times 10 to the minus 5, and therefore the resistance for the aluminium conductor will be 2,228 ohms. Okay, next question. Calculate the volt drop across the combination. Now it's important to note that voltage stays the same in parallel, so the volt drop across the copper conductor will be the same as the volt drop across the aluminium conductor. Now we just calculated the resistance for aluminium, so I'm going to use the current for aluminium multiply by the resistance for aluminium. Okay, so the current for aluminium, if we have a look at our diagram, is 35 amps, and the resistance that we calculated there was 2,228 ohms. So therefore the volt drop across the parallel branch will be 77,98 volts. Now in part C, we need to calculate the diameter for the copper conductor. So let me first write that formula down for us. So to calculate the diameter for copper, okay, and we're just going to go ahead. We don't get marks for manipulating the equation, unfortunately. So I'm just going to write down the equation that we will need. So it's 4 times A over pi. So as you can see, we need the area in order to calculate the diameter. Alright, so in order to calculate the area, it will be the resistivity for copper times the length of copper over the resistance for copper. Okay, so we'll need all of those values over there. Let's just put an equal sign over here. Now we've got one more step to do. We need to calculate the resistance for copper first. Let's write that over there. We need resistance for copper, and we need the area for copper. Okay, so to calculate the resistance for copper, I'm going to use the volt drop in parallel. Let's just call it the volt drop across copper. It stays the same. and we have the current through the branch for the copper conductor, ICU. Okay, so the voltage in parallel that we worked out was 77,98. And if you have a look at the diagram, you'll see that the current through the copper branch is 55 amps. So therefore the resistance for copper is 1,418 ohms. Right, now we can calculate the area. So the resistivity for copper is 0,018 times 10 to the power of minus 6. And the length of this cable is 1000 meters. And the resistance for copper, 1,418. So therefore the area for copper is going to be 1,269 times 10 to the minus 5. And don't forget, it is meters square. Right, now we can go ahead and finally calculate the diameter. So in order to get diameter on its own, it will be the square root of 4 times the area. So I'll substitute the area here. 1,269 times 10 to the minus 5 over pi. And that will give us our diameter. Now, first of all, if you have a look at the answer on your calculator, I'm just going to leave the answer in millimeters. So it's 4,02 millimeters. However, you can also write it in meters if you want. 4,02 times 10 to the power of minus 3, and that will give you an answer in meters. Alright, there you go. So we've solved the problem for two conductors in parallel. Thanks for watching this video.